In this tutorial, I'm going to give you a few tips on how to balance chemical equations. So we'll go through a couple of the examples that we've done on sheets in class. And so first thing I want to get you to do is to make sure that you use a pencil. At this point, since we just started this, you're going to be jumping back and forth and adding and erasing. And so make sure you use a pencil. Pen gets really messy really quickly. The second tip I have is just to look at your metals first. Your metals will often guide you, and if you balance those first, then the other ones may fall into suit, but they may not. So it's just a suggestion. The third suggestion is leave oxygen and hydrogens to the last. Now, because they're diatomic, they're usually in groups of two. So if you end up with an even number on one side, then it's easy to fix it on the other. Number 4, try to keep your polyatomic ions together. I'll show you one where it's beneficial to keep them together rather than trying to break them all up and think of how many of each atom there are. Just keep them together. And sometimes that's not possible though. Number 5, write water as HOH. And this kind of goes with the previous one where water is often written H2O, but can also be written as HOH. And sometimes that makes it a little bit easier to balance your OHs and your H's as well. And lastly, if you get to a point where you can't make it work out, try going back to the original and just doubling it and seeing what happens, or maybe tripling it. These are just suggestions. It is a puzzle. It is a game, I think, to kind of get these things balanced. So have fun with it and enjoy. So here's the sheet that we did in class, and I just wanted to show you a few examples just so see if you're doing them correctly and on the right track. I want you to think of this arrow as sort of the middle point of the balance, and that everything on this side of the equation must be the same, or the number of atoms must be the same as on this side. So all the reactants must equal the products, back to the law of conservation of mass. If we look at this, we can only add coefficients to the front. Remember, you can only just change the number, increase the number of molecules there are so that they add up to be the same. So initially you may start out and go, well, okay, there's 2 sodium here, and so you can fix it by putting a 2 here. Then you would notice that there is 1 O and 2 O's, and as soon as you put a 2 in front of this, it not only changes your O's, now you have 2 O's, but it also changes your sodiums to 4. So to go over and put a 4 to fix that. So 4 sodium here, and 4 sodium here, 2 oxygen here, and 2 oxygen here. So we'll try a few more here. For instance, this one. Okay, we have 3 bromine on the product side and only 2 bromine on the reactant side. We have 1 Al and 1 Al. Those are balanced. So let's fix that by putting a 2 here, but remember that doesn't just change your bromine to 6. We'll change that to 6. It also changes your aluminum. So you have 2 aluminum now, and you can fix that by putting a 2 there. So completely balanced. One of the hints I gave you earlier was to kind of write water as HOH. So I'm going to do that right here as this is kind of a good example. We'll change that H2O to HOH. And if I do that, you can see why I did that. There's an OH here, and there's an OH here. And then you just have to worry about these H's, right? So you have 2 H's here and just 1 here. So let's fix that by putting a 2. So you have now 2 H's and 2 OH's. So there's 2 H's, and we'll put 2 OH's. It doesn't just change your OH over here, it also changes your sodium. So that's going to mean that we have to change sodium over here to 2. So let's get over here 2 sodium. And then you have a balanced chemical equation. 2 sodium plus 2 water produces 2 sodium hydroxide and 1 hydrogen gas. All right. Let's jump down. Here's another example where I think it would be good to keep your ions together. We have an SO3. Just kind of keep those together. You have one SO3 here. You have 3 there. Or you have 2 boron and just 1 boron, and you have 3 fluorine and just 1. 1 lithium, 2 lithium. So I guess one of the things you could just try, you could just start with sulfates if you want. You could start with lithium. You could start with boron. You could just go. Let's just try boron. There's 2 boron here. So let's put 2 there, and that changes my fluorine to 6. So let's jump over here, put a 6. That also changes my lithium to 6. Jump back here. There's 2 already, so I can make 6 by putting a 3 here. 3 times 2 is 6. But that also changes my sulfates. Now I have 3 sulfates. But that's okay because I have 3 sulfates here as well. So the balanced chemical equation is 2, 3, 1, 6. Now I can totally see you starting another way. Let's just do it again and start, and you'll see how this becomes a puzzle. So there's 3 sulfates here. So we go over here and you'll quickly put a 3 here. So you make 3, and then 3 times 2 is 6. And you'd put a 6 here. 6 lithium. That also changes your to 6 fluorine. You go back over here and see 3. You put a 2, and that makes your 2 boron. You go over here, and it's already 2, so you can leave it as 1. So you can go that way as well. Let's try this one down here. This one has a polyatomic cation, so this is ammonium. And if you go over here, you'll see ammonium. Here's your NO3, and here's NO3. And we have a lead. We have some lead. And lastly, there's some PO4 and PO4. So I'm going to try to keep these all together and come up with a solution. I'm just gonna try 3 ammonium over here. So let's try to put 3 ammonium here. That changes not only my ammonium, but it makes 3 nitrates. So let's go over here, and there's 4 nitrates here, if you see. So there's 4 nitrates here. That's a problem, so we can't work this out. So now we have this factor of 3 and 4, and so I'm immediately thinking 12 is something that we're gonna have to do. So let's see if that works. Just because 3 and 4 is where I ran into a problem, and so just try 12. So let's start with 4 times 3, which is 12 NO. 12 ammoniums. Come over here, and we'll put a 12 down to make the 12 ammoniums. And now we're going to have to worry about the 12 NO3s. So if we come back over here, I can make, it's a 4, so I can make a multiple of 4 to 12. So that would be 3 times 4 is 12, right? But that doesn't only just change my ammonium, that also changes my lead. So I have 3 lead, but it's perfect because there's 3 lead there. So just another way to shoot through them, to try them. We'll do one more here. This is an example of one that really, you can't keep them together. They're a little bit different. So you have the PO4, but you have this weird H2PO4 polyatomic ion over here. You do have the sulfate and the sulfate. So you may have to do some other, you may have to break it up and just look individually, or you can just try some. Just you know that there's 3 calcium on this side, and there's 2 on this side. Sorry, there's 3 calcium over here, and there's 2 over here. There's 1 and there's 2. So you could just try some stuff. There's 2 PO4s here, 2 two PO4s, and then there's these two H's. So there's really four H's in this compound, so I'm going to try to put a 2 here. So that 2 times that 2 is 4. But that also changed my SO4s. I got 2 of those, so let's put 2 over here. And I also changed my calcium. So I have 3 calcium here, and I have 2 calcium here, but I also can't forget about this calcium. So I have 3, and I have 2 phosphorus here, and over here I have 2 phosphorus, and I have 8 oxygen and 8, so that's 16, and 4 times 2 is 8 in this molecule, and 8 over the 16, so that's balanced. So the coefficients are 1, 2, 2, 1. So that's balancing chemical equations. There's going to be lots of practice in class, and if you have any questions, please come and see me.